being able to extract equations from a tricky scenario, that is the most common and important topic on the AMC 8. Let's explore how we can approach them. So, the trick to solving these types of problems is to try and figure out the unknowns and just assign variables to them. But this is much easier said than done. So let's view some examples. Orangey loves drinking diluted juice. Orangey takes an 8-ounce glass of orange juice and drinks some fraction of it. So 8-ounce glass of orange juice, let's say the fraction that Orangey drinks is A. So A is a fraction. So Orangey drinks 8 times A ounces of orange juice. Right? Because 8 is the amount total, and then we take times A, because that's a fraction of orange juice that Orangey will drink. And I even made it orange. Okay. Then he fills the rest of the cup with apple juice. So 8A orange juice was drunk, and that leaves 8 minus 8. There's 8 minus 8A ounces of orange juice left. And then he fills the rest of the cup fully with apple juice. And that means that the cup fully is 8 ounces. So that means 8A ounces of apple juice is now in the cup. And he mixes it thoroughly. Okay, he then drinks 2/3 of this mixture. And because he mixed it thoroughly, he's going to drink 2/3 of the apple juice that's remaining and 2/3 of the orange juice that's remaining. So 2/3 of 8A equals 16/3 A apple juice, right? So 16/3 A apple juice, let's write that there. OZ of apple juice. And 8 minus 8A times 2/3, this is how many ounces of orange juice, how many additional ounces of orange juice Orangey will drink, which is 16/3 minus 16/3A. So what we have to do is add 8A to this quantity. So 8A plus 16/3 minus 16/3A. Right, this is the total amount of orange juice that Orangey has drunk. Cool, and we can simplify this because 8A, notice that is just 24A/3. And that leaves it with A/3A plus 16/3. And that is the amount of orange juice Orangey will drink. But how much is left in the cup? He drank 2/3 of the apple juice and 2/3 of the orange juice in here. So 1/3 of it will be left. 8/3 apple juice. Let's draw that here. And 8/3, so this is the amount of orange juice left. 8/3 minus 8/3 A. And also he has 8/3 A because it was 8A and 8 minus 8A and 8A, he has 8A by 3 apple juice left. Right? Okay, and he fills the rest with water. H2O. And he then finishes the whole glass. Cool. If he drank 4 times as much orange juice than apple juice total, how much total liquid in ounces did he drink? Okay, so notice how he drinks this whole glass. So he still ends up finishing all the apple juice and orange juice that was left. So what we could do is we could simply add 8A/3 to the amount of apple juice drunk because he drinks this whole glass, and for the 8/3 minus 8/3 A for the amount of orange juice drunk because he drinks the remaining amount. And we can simplify this for the orange juice quantity even more to get 8/3 plus 16/3, which is 24/3, which is just 8. So he drinks 8 ounces of orange juice, And then the amount of apple juice is just 8/3 plus 16a over 3, which is 24a over 3, 8a. Oh, but we're given in the problem, he drinks 4 times as much orange juice than apple juice. So 8 must be 4 times 8a. And that means that a is a fourth. Because then 8 is 4 times 8 times 1/4. So a is 1/4. Cool. But what is the question asking? How much total liquid did he drink? So we know he drank 8 ounces of. We know he drank 8 ounces of orange juice, 8 times a fourth, which is 2 ounces of apple juice. And how much water did Orangey drink? Well, the amount of water, notice here in the glass, there's 8/3 ounces of juices, right? If you add these two quantities up, the negative 8/3 a and 8 over 3 cancel. So 8/3 ounces of juice left, and that leaves 8 minus 8/3, which is 16/3 OZ of water left. So what we have to do is 10 total ounces of juices total plus 16/3 ounces of water. And that gives 30 over 3 plus 16 over 3, which is 46 over 3 ounces of total liquid that was drunk. Okay. So, therefore, the answer is just going to be equal to 46 over 3. And that is our answer. Let's summarize. So the key idea for this problem was just iteratively seeing the amount of orange juice drink and the amount left in the glass and being careful about it, and then noticing at the end that it simplified very nicely, solving a simple equation, and then realizing the total amount of liquid we could easily plug in and find. So a classic example of a word problem where the hardest part about the problem is decomposing this giant word jumbled into an easy algebra problem we can all solve. Cool, let's move on to this problem from the AMC 8. Rectangles R1 and R2 and squares S1, S2, S3 are shown below. They combine to form a rectangle 3322 units wide, so 3322 and 2020 units high. What is the side length of S2 in units? Okay, so let's see. Let's say A. Those are the 4 sides of S2. Okay? And let's say that S3 has side lengths B, 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 and B. And just to make it clear, I'll write them on the inside of the polygon. So A, and B, 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 B. So B is the side lengths of S3, and we're going to let C be the sides of S1. C, 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 C. Right? Squares have all sides equal. What is the side length S2? So what is A basically? A. Interesting. So the only condition we're given is this 3322 and 2020. So let's write that as an equation, right? The strategy is don't worry too much about what's going on, just convert it to an equation. They're much easier to deal with. A plus B plus C equals 3322, and that's going to be this equation over here, right? Because C plus A plus B forms the full side length 3322. Similarly, we have B plus this thingy, and this part is nothing but C minus A, right? Because this full length is C, this part is A, so this part right here is C minus A. So this side length is just B plus C minus A, which is 2020. I'm pretty sure you can guess which year this AMC8 was from. Okay, so we're trying to solve for A, but we have 2 equations, 3 variables. What we can do is B plus C. Notice those patterns like we discussed in the previous video. You can subtract these equations. The B plus C's will cancel, and if we do this, we're left with A. Remember, it's not going to be 0. A minus A, so A plus A, 2A equals 3322 minus 2020. That's going to be equal to 1312, right? So, 1302. So A is 651, and 651 is our answer. This is a cool problem, and believe it or not, this was number 25. So it goes to show that for these types of problems, the tricky part is figuring out the equations, and from there it's usually not that hard. So just assign variables to stuff you know, and try to assign as few variables as possible. Like you don't want to go assigning A, oh, let's call this D, and let's call this E, and try to assign as few variables as possible, and then try to find other side lengths. Like for example, rather than calling this D or something, we found that it was C minus A. So find things in terms of other variables. Okay, let's solve another cool problem. Tricky systems of equations application. Jar A contains 4 liters of 45% acid solution. 4 liters. This is jar A, and it has 4 liters. 45% of it is acid, so 45%, let's use blue, of 4 liters is acid. And this is 9 over 20 times 4, cancel, cancel, cancel. That's 1.8 liters, right? So acid, and yeah, jar C, or jar B, let's draw jar B here. It contains 5 liters of a solution that's 48% acid. So acid is now 48% times 5 liters, which is 48 is 48 by 100, and that's 24 by 50 or 12 by 25, times 5 liters, cancel, cancel, left with 2.4 liters. Cool. And jar C, this is a strange one. Let's move this up a little bit. Jar C contains 1 liter of a solution that's K% acid. So we don't even know the percentage. This is jar C, and the amount of acid is K% times 1 liter. So just K, or yeah, we'll just leave it like that for now. Okay, and you're given in the problem, from jar C, m over n liters of the solution is added to jar A, and the remainder of the solution is added to jar B. So we're adding some of the solution to A and some of the solution to B. So in total, we're adding all the solution to A or B. And at the end, they both contain 50% acid. So we're putting a little bit in A, a little bit in B, such that both the solutions are, such that all solution C is taken, so that A and B are now 50% acid. So notice here that they're a little bit less than 50%. So by adding this, it's going to increase its percentage to 50. But we're trying to find how much do we really need to add. How many liters of the solution to A, how many to B. And also, what is the percentage, K? Interesting. So there's a slight observation here that's going to simplify the problem a lot. The thing is, they're both 50% at the end, right? And what does that mean, right? A will be 50% at the end, B will be 50% at the end, after adding parts of C, right? You can think of dividing C into 2 parts. This is the part that will be added to A, and this is the part added to B. But the key thing here is, because we're adding all of solution C, the total amount of solution, if you look at all of A, B, and C combined, that will also have to be 50%, right? Because after adding this amount of solution in C to both A and B are each individually 50%, which means that them combined are also 50%. But remember that the combined solutions are just A, B, and C, the original solutions A, B, and C. And that must be 50%. So that means So there's total of 10 liters among solutions A, B, and C, right? 10 liters total. From that, 5 of them, it must be 5 liters acid. 5 liters of the 10 must be acid. And we already found 1.8 in A, 2.4 in B, which means 0.8 in C. This is equal to 0.8 liters. K is 80%. We're not done just yet. We still have to find out how many liters of the solution do we have to add to jar A to make it 50%. And to do this, this is just an equation to form. So let's say we're adding the fraction A. Let's say X, just to make it easier. So let's say we add X, which is where X is a fraction of the solution C, to A. So A originally is 1.8 liters of acid and 4 liters of total liquid. But after adding some fraction of the solution C, X, the fraction, we're adding 0.8. I'll remove the units for now. 0.8 times X liters of acid and just simply X total liters of total liquid. And this has to be 50% or half. Cross multiply, 3.6 plus 1.6x is 4 plus x, and we can subtract x from both sides to get 0.6x equal to 4 minus 3.6, which is 0.4. So x is 2/3. So the fraction is 2/3, and it says, and if the fraction is 2/3, because the solution is only 1 liter, the amount of solution C we're adding is also 2/3. So therefore, this fraction over here, the amount of liters added to jar A is just 2/3. So we discovered K was 80%, and then the fraction was 2/3. So M is 2, and N is 3. So plus 2 plus 3, right? K plus M. That's 85, our answer for this problem. Let's quickly recap. So the key idea here, look at jar A, find the amount of acid. Jar B, find the amount of acid. Jar C, find the amount of acid in terms of K. And then realize this key observation that both jars in A and B contain 50% after adding the solution, after dividing the solution C amongst them both. But that means that the total solution combined must be 50% acid. We use that to find K and then solve a simple equation over here to find the amount that we had to add to A to make it, 50% acid. We do that, we do the extraction, we get 85. So in general, you can find all of these practice problems in the Mastering AMC 8 book, link in the description. But now we're ready to move on to the next topic, which is going to be speed, distance, time. And they're very similar to these types of problems, except now we're dealing with speed, distance, time equations. Let's see next time right over there.